Okay, this is workbook 6, which is in Unit 2. It's the beginning part of Unit 2. So if you took that unit exam for Unit 1, then here we go, next start. So hope you're able to finish that Unit 1 exam. So here we go. We are going to be talking about rigid transformations. So just a little general idea, rigid transformations, what that means is that they're transformations, so like doing stuff to a figure that keeps the figure the same shape, the same size, the same side lengths, the same angles, everything stays the same. It's just that it moves it. That's all it's doing. So it might reflect it, might turn it, might just slide it across the thing. And so we have three main translations that we have for this one. So the three translations are our transformations is we have translations, which you can also call a slide. We have reflections, goes back and forth, or we have rotations, which just means a turn. So those are the three ones. So if you look here, we're going from the blue to the pink. The blue ones we call the pre-image. The red ones we call the image. So before you do something, it's called a pre-image. After, it's the image. Notice that there's a little kind of like apostrophe on these things. That we call that prime. So we would say this is A prime, B prime, D prime, E prime, F prime. So those are all primes. And for that one, we moved 4 units to the right and 2 units down. So that was a translation. Next one, we have reflections. You can have reflections across a line like this. It might be across a horizontal line, might be across a vertical line. But the main thing with that, when you do a reflection, is it'll be the same distance away. So notice from G to this line is about like 1 diagonal away, and then so is that. That's about 1 diagonal away. Or this, let's see, same thing here. That distance there is the same as that one. So that's a reflection. Again, pre-image, image. Last one. Oh, and then they have this clever thing right here. If you reflect it across the x-axis, notice that if we had the point right that was right, some point right here, notice the x's stay the same if it's across the x-axis, but the y's, they're opposite. So if it was negative, once it reflected over the x-axis, it becomes positive. Or if it was positive, it becomes negative. So the only thing that changes is the y. The number stays the same, it just goes back and forth between positive or negative. If it was across the y-axis, the y stays the same and the x is opposite. And if it was diagonal, then the x and the y switch places. A perfect diagonal, the x and y would switch places. Last one of these three was rotations. So we have the rotation, we have things, we have the center of rotation. And imagine this being, if that was the origin, imagine that's like your elbow sitting on a table, you take the shape and then you turn it. So it's going to stay in that same type of thing. If you ever watch a clock, secondhand tick, it looks like that. If you don't watch that because you don't have an analog clock that does that, then yeah, that's going to be confusing. So you have your pre-image and your image. This one rotated 130 degrees. So that, how much it turned is called the angle of rotation. And then we have the center of rotation. And the same word is the pre-image and the image. Okay, so then we have to identify what the transformation is. That's what we're doing with these things. So we're going to match each type of the transformation with the correct description of that transformation. So a rotation, for rotation, we're looking for an angle of rotation. Translation means like up, down, left, right. Reflection would mean you'd have a line of reflection. So let's look here. So mapped in the same distance and direction. We're looking for center of rotation. Oh, right here, center of rotation. So that's it. Translation, same distance and direction. That's it. And then reflection. Reflection would be pre-image mapped onto the line of reflection. We're looking for line of reflection. Okay. Next one, we have these. So ABC has been transformed in 3 different ways, and we want to know what they are. So let's see, D, E, F turned. So B turned. It was a rotation. So because it's pointing up and now it's pointing to the left. So it turned up this way. So that would be a rotation. GHI looks to me like they just slid it straight down. So that's a translation. And then JKL, you could reflect it across this line right there. It just goes straight down. So that would be a reflection. And then use the following to answer that question. How do we get from this one to that one, blue to red? I would say that looks to me like it turned, because this from here, you always do it compared to the origin. So from A to here, it turned that much. And that much is 90 degrees. So 90 degrees counterclockwise about the origin, which is the same thing as going 270 the other way, 270 clockwise. So 90 degrees counterclockwise is the same thing as 270 clockwise. And okay, good. Next one. What happened here? How did you get from blue to red? I'd say it's a reflection. So a reflection, and then it preserved side lengths, and it was a rigid transformation. So it stayed, all those three things stayed the same. If it doesn't, is a non-rigid, is a result. So it's a result of a translation. Nope, it was a result of a reflection. So reflection, preserve side lengths and angle measures, and that was what rigid transformation means. So three things were answered on that one. And then this last time one, I have to draw this. I actually have to draw it. So let me see if I have anything to draw with. I do, and I'm drawing with a mouse. So it says, draw a line. Okay, now draw a line perpendicular to the first line that passes through point G. So here we go. It says it's not at the intersection, so I'm going to call that point right there G. That's supposed to be G. Yep, that's good. Measure the distance from G to the line. Draw another point on the second line that is the same distance from G on the opposite side. So that's going to be up here. So that's going to be the other one. So we have this pre-image, and the other one is the same distance up there, which is a reflection. Okay, there you go. My lines are staying there. Okay, so you get 100% on that. Next one.